Hey everybody, I'm Vince from a channel I call Mr. Endris' Science Brainery, and I'm a 20-year-old, not 20-year-old, but a 20-year middle school science teacher, and I've been with NGSS since its inception. I've been working with it, and I figured I'd just make some videos. I will call this video number 1, and see if I can help you out with some of the questions that you might be having about NGSS, and especially how to implement science standards. What kind of order do you go with? What kind of things do you make sure that you want to teach, have to teach? And so we'll go from there. One of the things that I do want to say is, while some of these videos will be over like the certain performance expectation and what to cover in order to cover that, which students should be able to do in order to cover that, it's really supposed to be as a whole. Like, these things aren't written to be taught in a vacuum. They have to be taught all together, and so that's what's supposed to happen here. But what I like to do is I like to look at each standard, figure out what I'm supposed to do, and then, or what students are supposed to do, and then I can kind of put it all together. This is one of the biggest things, the biggest questions that I always get is, what order do you teach things in? And this could vary from person to person and really state to state, because different states have adopted different amounts of the NGSS, or maybe they've adapted in their own way. Some states do it, earth science all the way through, and some states do it earth science, a little bit of everything. So depending on where you are is kind of dependent on what you want to teach and in what grades you want to teach it. I'll tell you, for earth science, what I do is I like to start with the earth and then make my way through and end with solar system. So I skip the very first 3 of the NGSS, like the sun and the planets, order of the planets, and all that stuff. I put that at the end. So that's my own personal preference. By the way, I may say numbers a whole lot, like ESS 1.1, ESS 1.2. If you don't know what that is, you need to find out. Okay, all that is the actual performance expectation, and so I try not to say that too much because people don't know exactly what I'm talking about. But I'll say this is what the performance expectation is, or this is what we need to try to teach. And so what I'll do is I start off earth science. So this is the beginning of earth science. Okay. By the way, I'm not going to make any edits on this video. I decided, I'll make this kind of like a podcast, except I don't have any idea how to do a podcast. So you can listen to this in your car or whatever. But I figure a straight stream through is going to help me more than having to go through and edit all these videos. So please forgive the many mistakes that I make and my incessant rambling, because I tend to do that. All right. Also, send me any questions you might have. All right. The way that I do it is I start off with like the beginning, in the beginning, and I'll say this is how the world came into being, or at least this is what our best evidence suggests. And by the way, that's a terrific way to communicate that, because what we're doing is we're trying to get students to realize that there's a connection between things that we can show and what we think. Okay, and I always stay clear of those words, fact and prove, because, and I know people have a hard time with that, but because facts in science change. And you say facts can't change. Well, no, but that's why I don't use the word facts, because we change the way that we look at things depending on the evidence that we have. And so when I talk about what happened, how was the earth formed, or how the earth become, I'll talk about, well, these are the evidences we have to back up that claim. So you might know claim and evidence and reasoning. That's a big thing in science nowadays. And so our claim is like, this is how the earth formed, and this is the evidence behind that. So as you go throughout your science career and your science classroom, I would urge you to kind of steer clear of telling students like, this is how it is, and I would always go towards the best evidence we have suggests this, because that's how science is done. The best evidence we have shows this is what's happening. It could be that later more evidence or better evidence shows something different, better data. So we rely on data. Well, from what we can figure out, it looks like as the sun was forming, basically you had all this debris floating around in space. You had gases floating around in space. You had heavier elements floating around in space. So metals floating around in space, rocks floating around in space, minerals floating around in space. And because there's nothing else around them and everything has gravity, they all start to clump together. This is called accretion, and they all start to clump together. There was a really cool YouTube video you can actually watch of this, but a cool kind of experiment done by a NASA astronaut who took some salt into space, and they had it in a Ziploc bag, which you can imagine if it gets out, the havoc that would wreak, because it would just float everywhere, and it'd be hard to stop it. But if you watch it in the Ziploc bag, what's happening is that it starts to clump together. It starts to accrete. And that's because even little salt molecules have gravity, right? And so all the salt is sticking to all the other salt, and it's accreting. It's getting bigger and bigger. And this seems to be, or at least this is the leading theory on how planets formed. You had all this stuff floating through space, and it starts to clump together. The bigger stuff attracts the smaller stuff, and it just clumps and clumps and clumps until eventually you have this huge spherical object floating through space, and it's being pulled by gravity, so it starts revolving in this spherical plane around the sun. But the big important idea is that it's all clumping together, and it's not a solid because it's way too hot to be a solid, and so you really have this just liquid rock and metal thing floating through space, okay? And then what I do is, now, by the way, this isn't a standard yet, so we're not on the performance expectations. They don't mention this stuff, but in my, well, I'd say in my experience, but to me, it's hard to grasp what's going to happen to the Earth and things that are happening to the Earth. It's hard to grasp plate tectonics if you're not getting this. So you really need to, in my opinion, teach this before you start into any of the Earth's processes, because those Earth processes happen because of the way the Earth formed. All right, so that's why I start off. My very first thing to teach is this is the formation of the Earth, so that we can start figuring out why the Earth works, why we have the processes we do. In the ESS 2.2, they're called geoscientific processes. So this geoscience process is going to happen because of the way the Earth formed. We're also here going to deal with a lot with convection, and convection currents are going to be really big as you go throughout science. So Earth science especially. So this is a place to start teaching that. So what we do is we make a little model. Say, well, we're going to model what the Earth looked like when it first formed. Okay, and so we do that in a beaker. You can do this as a demonstration, or you can actually give this to your students. This is the way that I do it. I give them this, and I tell them what to put in there. And we will put in some iron, like washers or something like that. I'll put corn syrup in there, and I'll put water in there, and I'll also put something like styrofoam in there. And the reason why is because they're going to separate by density. So here I have the early Earth, okay, and it's this big clump of magma, and you can put these things in there, and you'll notice that the iron is going to sink to the bottom, right? So this is going to be the iron washers or iron metal, iron steelies. You play marbles with them or whatever, and that's going to sink to the bottom. The second thing is going to be that corn syrup. It's going to happen right here, okay, and then on top of that is going to float some water, and then on top of that is going to be floating my piece of styrofoam, okay, or anything else that will float on top of it that's solid. Now, what I've done here is it's created the layers of Earth. This is why Earth has the layers, right? Because as you go down, density increases. This is where it's densest down here, and then every layer just kind of floats on top of every other layer. And now the reason I use corn syrup right here, by the way, you could use just water, and then you could use oil, because oil is a liquid, you just want two liquids. But the reason I use corn syrup is because I'm going to do another activity in just a moment where I'm going to make this layer water again. And so I like to have that consistency so it doesn't confuse the students. Well, we called the mantle oil at one point, and then now we're going to call the mantle water, and I don't want anybody to get confused. So I have my densest layer is iron, and then this is going to be my inner core. This is my outer core. Outer core is also made out of iron and nickel, but now it's a liquid. This is actually going to be my mantle, which means it should be thicker than this, but oh well. this is my mantle, and a lot of people call the mantle, well, don't call it. I mean, there's a difference between the mantle and the asthenosphere, and some people will really break that down, and they think that's important. It might be. It used to be important to me, but now on this level, I think, middle school students, just call it the mantle. You don't have to get confused with what the asthenosphere is. Same thing for this top layer. I just call it the crust. It's not the exact same thing as the lithosphere, but I'll just tell them those two things, they're not the same thing, but we're just going to talk like they are the same thing. Okay, so here I have my inner core, outer core, my mantle or asthenosphere, and my crust or lithosphere, and they're all floating on top of one another. So that's how the world was separated into layers. Okay. Another thing about the mantle that I like to point out, that you really should point out, is this is made out of rock. So these two layers are made out of iron and nickel. These two layers are made out of solid rock. Well, if it's solid, why do I have the liquid here? And so I let students know, well, that's because even though it's a solid, it flows like a liquid because it's so hot. Okay, so we might do things like with silly putty. If you heat up silly putty, you'll notice it starts like and Play-Doh, the same thing. It's a solid, but everybody knows it looks kind of like a liquid. But also, as you heat it up, it starts to become more like a liquid. But it's still a solid, and so that will let the students know, hey, this acts like a liquid even though it's a solid. Okay, so there's our layers of Earth. The second thing is that now we'll do another experiment or activity where I'll give them another beaker, and this time we're only going to deal with the mantle and the crust. And so I'll give them some water here for our mantle, and then they'll put some styrofoam things, or anything that floats on there really, like a sponge I've used before. But anyway, these things float on top of here, and what we'll do is we will heat it up. Okay. And by the way, this is a really good opportunity to talk to them about models. Like, we model the layers of Earth. Models are very good for some reason, like that's why we use them. Like, what does this model have that's good about it? But it's also good to ask, what's the limitation? What is the thing that is not good? Sometimes students don't get that question. They'll say, well, it's not the real Earth. Yes, I understand it's not the real Earth. But what's bad about that? And it took me a while to figure this out. But what we're really asking is that if students thought this was it, like this is the real thing, I've just modeled everything is perfect, this model's perfect, what are they going to be missing out on? And so that's always how I present it to them now is, what's the limitation? What if you thought this is the real thing, what might you misunderstand about the real Earth? And one of the things about our last model was it doesn't have heat, and the real Earth does have heat. And because of that heat, we're going to see things happening. Okay, so I heat it up. If you do this in class, especially if you let students do it, you really need to do it beforehand so you can figure out exactly how long they need to have that burner on, because this will heat up pretty quickly, and yeah, so you don't need it boiling. What happens is that this water will start heating up just like it is boiling, and the hot water, they don't see this just yet, but the hot water is going to start going up, and when it gets up here, it's going to cool down, and it's going to start going back down. Okay? And this is called a convection current. Convection currents happen just like in boiling water. This happens in the water cycle. This is how wind is made. Convection happens when things get heated up and they start rising like a hot air balloon, and then they cool down at the top because they lose all that heat, and it comes back down. Okay, so that's why this is happening. And what they're going to do is you can have them put food coloring in here, and the food coloring will show that start happening. So let them watch, and they can see that food coloring start happening, start going in convection cycles. And then you just take these things on top, and you can have them try to put it in the middle, and it will keep moving over the side. Like sometimes very dramatically it'll move. And the reason why, hopefully they can figure this out, you can have them write this down or make a connection. But the reason why is because they're on top of these convection currents. So it's moving them, it's pushing them, right? This is going to be how the plates move. By the way, me personally, I don't introduce plates. I kind of, some of them know about it, and so I'll say, yeah, that's the plates. But I really don't talk about what the plate boundaries or anything yet, because I have another activity that we're going to do after this one to investigate the plates, and that's going to deal more with ESS 1.3, which is looking for evidences for plate motion. But anyway, this is a geoscience process that they need to know that we do have these convection currents happening down here, and it can move this on top. And so I let them know that, like, this is the Earth. It gets denser as you go down to the bottom. It also gets hotter as you go down to the bottom. And one of the biggest things to point out here is the heat, right? Because these standards are going to be a lot about where that energy goes, especially the first standard on the rock cycle. Well, what's happening to the heat here? Well, right now, the heat's just permanent. It's always there because I have it on this burner. But if I turn the burner off, these convection currents don't stop right away. Okay, they keep moving this, and then it's going to lose heat. So the heat's actually being lost. And so that's important for students to know also, that the core of the Earth is cooling down because it's losing heat. It's moving the mantle is moving the plates, and then the plates are moving because of that heat being lost into the atmosphere. Another thing you might do is, with these things, I'm thinking about it. In fact, hey, you know what? You've helped me out because I'm actually going to do that right now. I'm going to do that next year with my students. I was thinking put some foil on there, but make a little cup out of it. Foil sinks, by the way. It is denser than water, but if you can make a little cup out of it, it'll float like a boat, And so if you do that, I'll just put a little bit of water in there. Have them put a couple drops of water, and then it'll float around, and so you can show them that there's two types of plates. There's a continental plate, and there's also an ocean plate. And the ocean plate, by the way, is not made out of ocean. It's still made out of land. It's just that it holds ocean. So I think that's an important thing. Anyway, that's it for episode number 1. All right. Hopefully it'll get you started on earth science. And then we'll build into the big concept next of plate tectonics, and then we'll move into how the landforms are happening, which is ESS 2.2, and how the rock cycle works. That's ESS 2.1. So I'll catch you next time.